Hi friends, welcome back. Now let's begin our journey into implementing various tasks on a single linked list. So let's begin our journey from creating a linked list. So we want to create a linked list and we want to say that the first node is called head. So we have to define a node. A node consists of two parts: data part, address part, and the name of the node can be given differently. So in this case, the first node we can call head node or header node. Then this we can call second node, third node, fourth node, and so on. So this can be the name given, and each node we can have data for that and address for the next node. If there is next node, we write address of that. If we don't have, then we just write a null as we have done here. So let's see how this is done. So first thing is we need a structure because node consists of two data or two information. One is the data, and the data, if we work with a set of integers, then let us define data as an int. And then we need a pointer to show where the next node is. Therefore, we need a pointer to the structure node, and we call that pointer as a next. So we define a structure called node, which consists of two parts. One part is called data, which is of integer type, and another part is called next, which is a pointer to a structure called node. Yeah, so let us see how a new node is created. So to create a new node, so we use this function new node and pass on the variable data, which is of type integer, and this new node function should return a pointer to a structure called node. So here we define one temporary variable for our pointer to the structure node, and then allocate memory for storing the details of one particular node. So what all details are required? One is to store the data and another is to store the address of or memory address. So data, when we say in C language, it needs 2 bytes, and when you say address, then it may use 4 bytes or 8 bytes depending on the type of C we are using and the operating system we are working with. So whatever it is, so we are not bothered about how much is the size of address and all that. It is taken care by this one line, the size of structure node. So what is node? Structure node contains two elements. One is data, one is pointer to the another node. That means address where a node is situated called next. So then we say the data part of this node, whatever we have defined, allocated memory for that, the data component of that is copied with the data we have supplied through this as a parameter to this function. And because this is the only node we are creating, we don't know what comes next. Therefore, currently we say that there is no next node. So by default, we say that the next node is null. So we have created one node, the data component we have copied from what is supplied as a parameter while calling this function. And because only one node we have created here, so there is nothing like next one. Therefore, we don't have any next node, so we write null, and this one is returned. So if I want to create a new node, I just call this function new node and work on that. So let's see an example on that. So here we have defined a structure node consists of two elements, data and the pointer to the next node. And here we have created one node named first and allocated memory for that. And the data into this node we have assigned equal to 10. Then we have created one more node called second, allocated memory to that, and the in the data position we have written 20, and the third node is again created, define the memory, allocated memory, and in the data part we have written 30. So while creating these nodes, it is only data part is being written here. That means by default, what is happening is the next part is set to null. Now it is our duty to create a link so that this whole thing comes in one chain. So we say that the next node of first is the node called second, and the next node of second is the node called third, and next node of third we don't have any fourth node, therefore we just put it null. So this way a linked list is created. So when we say this line, when it is executed, one node was created, data was entered as 10. When this line was executed, node was created, data entered was 30. Then here 30 is entered, and when we run this line, then node with 10 is connected to node with 20. That means you start with a node having value 10, the next node we are pointing to another node whose value is 20. After this we have pointed to 30, and after this we said null. That means we start with 10, then go to the next one, it is 20, then go to the next one, it is 30, then go to the next one, null. That means we have only 3 elements in this node. Now we want to just print this. So we created one temporary node, and we assign that to the first node, and then we keep on moving as long as the next node exists. So in the first case, temp is the first node, then we just print the data of that temp. Temp is the first node, and then we change the value of temp to its next. So it started with first, then first next is second, then on back, then second's value is printed, then second's next is third, third's value is printed, then third's next is null. Therefore, while null doesn't work, therefore it comes out and just returns 0. So let us see what happens if we run this. So the linked list what we are getting is 10, 20, 30. So let's just change this and see how it happens. So instead of 10, 20, 30, let me make it 100, 200 and 300 and see what happens. So I just rebuild that. Yes, we have a new linked list. Then the elements are first element is 100, second element is 200, third element is 300, and so on. So that's how linked list can be created. Other operations, other implementations, we look in our coming videos. So keep watching. Thank you.